Here's a follow-up lesson on lesson 57, building sine and cosine functions. We've flipped the script a little bit since the previous lesson. Before we were describing the changes made on a given function, a given equation. What we're doing now is we're creating that equation based on criteria. So let's do a couple of these. I'm going to move through them quick because they're all a little different. If you feel like I'm moving too quickly, you could slow down the playback speed of the video or feel free to watch it more than once. What we're going to do first is number 1, identify a sine function that has a maximum height of 7 and a minimum height of -1. So a sine function, I always like to draw a little graph. It looks like this. So sine looks like this. It says that I have a maximum height of 7 and a minimum height of -1. Now I need the midline in order to create a function, so let's average these two together. 7 plus -1 divided by 2. That's going to be 6 divided by 2, which is 3. So this line here in the middle, the average value, is going to be y equals 3. I can count that, actually. I don't have to just assume that, because think about it. 3, 4, 5, 6, 7. 3, count down, 2, 1, 0, -1. So it's 4 up, and it's 4 down. So that means that my amplitude must be 4. There are no other criteria that I need to fulfill, so I'm just going to write this one out. Y equals, remember the amplitude comes first, 4 sine of x, and the midline goes on the end. Cosine function is exactly the same way. This one's exactly the same way, maximum, minimum. So let's go to a function that's a little bit different. Question 6. We're going to identify a sine function that has an average value of 6, a maximum height of 10, and completes 4.5 cycles in a standard 0 to 2 pi window. Completes 4.5 cycles in this window. That's literally the definition of frequency. So the frequency is going to be 4.5. Now, let's draw a little diagram again. Average value of 6, maximum height of 10. And it is a sine function. So a sine function looks like this. As an average value of 6. An average value is the midline. Mid even sounds like middle, which is just like average. It has a maximum height of 10. So let's take a look at this graph. What's my amplitude from 6 to 10? 7, 8, 9, 10. So we go up 4. 1, 2, 3, 4. Rather. And that would mean that my lowest value is 2, but we didn't need that. All I need is y equals, and it's still sine, 4 amplitude, sine of how many x's? 4.5x plus 6. If you're confused at all, remember that in the beginning goes the amplitude. On the inside, right next to the x, goes the frequency. And on the end goes the midline. Now you have a bunch that are just like that below it. So if you understood what I did on 6, try 7, 8, or 9. That's what we did in class. I want to move to the back. I actually want to delete some of those to begin with. I suppose I don't actually need to. Okay, so these are just like the last question that we did. They have an average value. Let me not erase. They have an average value, they have a maximum height, and they tell you how many cycles they complete from 0 to 2 pi. So if you go through and you complete these questions, this is what you'll get for 12, 13, 14, and 15. Now, sine at 0 radians always starts at the midline. Unless it has some sort of a horizontal shift, it'll always start at the midline. So standard sine function has a value of whatever the midline is. If we're talking about question 15, as it states here, then our midline is positive 3. Now 17, if the function had a peak at pi over 2 instead of 0, how would I shift the function pi over 2 units to the right? Well, regardless of what function we're talking about, if I wanted to shift something pi over 2 units to the right, I would have to subtract pi over 2 on the inside of the function next to the variable. So I gave an example here of how I would turn a cosine of x function into something that's shifted pi over 2 units to the right, which would be cosine of x minus pi over 2. What I did next was I asked you questions about modifying functions that we already had. Now, number 12's function, but with a horizontal shift pi units left. What I'll do is I'll give you the original one, and then I'll modify that, and then the rest of this can be your responsibility because I don't want to give you all of the answers because these were homework questions. Number 12's function was y equals 2 cosine of 2x minus 2. That was the original. But what they want me to do is they want me to modify that again. Now, building a function is piece by piece. We find the amplitude, we find the midline, we find the frequency, and we put these all together bit by bit. So it's all about starting with an uncomplicated function and adding in these modifications bit by bit. So let's start with this, and let's shift it pi units left. Pi units left means we'll be adding it. So we'll be adding it on the inside over here. So I'm going to rewrite this, y equals 2 cosine of 2 x minus pi instead of regular x minus 2. So all I did was I took the I took the x and I changed it into an x minus pi, and then I put that right in the spot where it came from. And that's all you do to make changes, to make shifts. So 2 radians to the right means that we would be doing minus 2 on the inside of the function, and you can figure out what that looks like based on my example for number 18a. Okay, so good luck with that, and I'll see you in class.